Welcome to Smart Charging Part 3, Energy Optimization and Cost Control. In Part 1, we looked at load management, keeping your site within its electrical limits to avoid tripping breakers or overloading infrastructure. In Part 2, we explored charging strategies, how available power is allocated across vehicles so the right ones are ready on time. In this final part, we focus on the third layer of smart charging, energy optimization and cost control. This is where smart charging directly affects the bottom line, through when energy is used, how demand spikes are avoided, and how tariffs and utility signals are managed as fleets scale. As fleets electrify, energy costs are influenced by more than total electricity consumption. At a high level, three factors drive how costs emerge: when energy is used, how much power is drawn at any one time, and how charging responds to wider grid conditions. These factors sit underneath electricity tariffs and largely determine whether energy costs remain predictable or become volatile as fleets grow. These factors become more pronounced as fleets add chargers and move from basic AC charging to higher power DC fast charging, and in some cases operate sites dominated by DC chargers. This evolution often places fleets onto new electricity tariff structures. Retailer tariffs influence the price of energy by time of day and season, while network tariffs reflect how intensively and how quickly power is drawn from the grid. As electrification increases, fleets are increasingly exposed to pricing linked to timing, peak demand, and grid responsiveness. The first factor is when energy is consumed. Most fleets have some flexibility in when vehicles charge, particularly overnight or between shifts. Instead of charging immediately when a vehicle plugs in, charging can be scheduled around tariff structures and vehicle readiness requirements. This allows a greater share of energy to be purchased in lower cost windows while ensuring vehicles are ready when needed. The second factor is how much power is drawn at once. Many utilities charge not only for energy consumed, but also for the highest power spike created during a billing period. One unmanaged fast charging event can set a high demand charge for the entire month. Managing how charging sessions stack and overlap is critical to controlling these costs. The third factor is how charging responds to grid conditions. In many regions, utilities and network operators signal periods of grid stress and offer incentives for load reduction or shifting. Fleets that can adjust charging in response to these signals can access incentives, reduce risk, and position themselves as flexible, grid-friendly loads. To unlock these cost optimization strategies, fleets need a few key building blocks. First, tariff and time of use data. Your system needs to understand what electricity costs at different times of day. Second, load profile monitoring. Visibility into how your total site load behaves over time, ideally with real-time metering at the site and keyboards or feeders. Third, optional integration with demand response or OpenADR style interfaces, so the system can react automatically to grid or price signals. Combined with load management and charging strategies, these inputs allow a CMS to make cost-aware decisions without sacrificing reliability or readiness. Viewed together, you can think of smart charging as a maturity ladder. At the base are basic strategies like even distribution or simple sequential charging, which need only OCPP capable chargers and a CMS that can set charging limits. As fleets mature, they add intermediate strategies like priority-based charging, blending in state of charge data, departure times, and per charger metering to improve readiness. At the advanced level, they adopt schedule-driven charging and load following backed by real-time site and feeder metering and high-resolution state-of-charge data. Finally, at the top, they layer on cost optimization strategies, TOU optimization, peak demand management, and utility signal response. Each step adds more control, more predictability, and more economic value. A fleet-focused CMS like Better Fleet is designed to support this full hierarchy. It can enforce site, board, feeder, group, and charger limits to protect infrastructure, apply charging strategies that align with duty cycles and dispatch schedules, and then schedule charging into the lowest cost windows while smoothing out peaks and responding to utility events. For some fleets, this has meant avoiding or deferring major capacity upgrades, reducing energy and demand costs, and still achieving very high readiness and uptime levels. In other words, you get more vehicles charged at lower cost on the infrastructure you already have. Smart charging isn't just about getting electrons into batteries, it's the operating logic that determines whether your depot is reliable, ready, and cost-effective. When you manage load at every electrical layer, choose charging strategies that match your operations, and optimize when you charge to match cost windows. You turn limited electrical capacity into predictable operational capacity at a lower and more controllable cost. If you're looking at your energy bills and wondering how much of that could be reduced with better load management, smarter charging strategies, and cost-aware scheduling, we'd be happy to explore it with you. Reach out to the Better Fleet team, and we can help you assess your site constraints, understand your tariff exposure, and design a smart charging approach that improves readiness, lowers total energy cost, and sets your fleet up to scale with confidence.